Everyone, my name is Ridhan Pokri and I'm from 7C, and today I'm going to be doing a science experiment called the Dragsters. So let me tell you my problem statement. My problem statement is that I have to create a cart which travels with the aim of 5 meters, carrying a load of 200 grams for someone who's suffering under the deadly virus of COVID-19 and is in home isolation. To resolve this problem, I have created a dragster which uses inertia and Newton's first law. An object at rest tends to stay at rest, and an object in motion tends to stay in motion until acted upon with an external net force. Newton's first law is also known as the law of inertia. Now you might be wondering, what is inertia? Well, inertia is simply an object's tendency to keep doing what it is doing, whether it be staying at rest or staying in motion. Now let's move to my research question. My research question is that how will the amount of clay I put on the back wheels affect the distance that the car travels? Now let me tell you my variables. My independent variable is the distance that the car my independent variable is the amount of clay I put on the back wheels. My dependent variable is the distance that the car travels. I will be measuring it in meters using inch tape. And my constant variables are the air pressure, the gravity, and the medium in which the car is traveling in. Now my control variables: the dimension of the cars, the materials used, the load it carries, the basket, the diameter of the wheels, the propulsion fuel or trigger of the car. Yes. So now let me tell you my hypothesis. My hypothesis is that the car which has a fair amount of clay on the back wheels will travel the furthest distance, as it will have a good amount of inertia which will keep it in motion and for however long, and it will be easy to start and easy to stop. Now let me tell you my main materials which I used: popsicle sticks to frame the framework, and then elastics to bind the popsicle sticks together, tape to reinforce the binding of the elastics, and I used shish kebab skewers as my axles, cardboard as my wheels, and I also used three Duracell batteries which weigh 200 grams along with it, and a basket, and finally my inch tape. So now let's start racing these cars, shall we? We are going to start with with the first car, which is labeled B at the starting point, and my aim is to reach 5 meters, which is labeled with the tape right there. So let's start with car B. Let's put the load on top of the car and let's start in 5, 4, 3, 2, 1, go. Well, it didn't travel too far. Now let's move to car number C, which has a fair amount of clay on it. And now let's move the load onto car number C. One, 2, 3, go. Wow, it traveled quite far. Now let's move on to the last car number D, which has a lot of clay on the back wheels. Put the load onto car number D, and let's start in 5, 4, 3, 2, 1, go. Well, it also didn't travel that far. Now let's use inch tape to measure how far the car traveled. Sorry.
Continue.
After reviewing the measurements, here are the results. Car C traveled a total distance of 0.52 meters. Car B traveled a total distance of 0.37 meters. And finally, car D traveled 0.24 meters. This is only trial 1. I will be conducting 2 more trials to calculate the average speed of these cars. Average distance that these cars cover. Sorry. So until then, bye. Excuse me, sorry. So let's continue. I have something else to say. Car C, being the car which had a medium amount of clay on the back wheels, traveled the furthest, thus proves my hypothesis correct, as the more mass you apply, the more inertia is gained, and this ties up with, again, Newton's first law: an object at rest tends to stay at rest, an object in motion tends to stay in motion until acted upon by an external net force, which is, of course, in this case, which eventually stops the car, is friction, right, between the ground and the wheels. I can clearly tell that. So I'm going to be reinforcing the trials again and again to get the average distance that the cars traveled. Until then, bye.